Right. So in the last class, like I have been talking about, we created a table called taxi data in Hive, and we loaded the New York yellow cab taxi data. And then what we did, we also queried the data. We ran some very basic queries like calculating the average fare, what percentage of the total amount is given as toll, etc., etc. We ran some very basic query. So we understand that Hive is nothing but a SQL engine on top of Hadoop. And the queries that we are running using Hive, it is getting converted into a series of map-reduce jobs. So we have already understood this. And another important concept um, which we started discussing in the last part of the class was that there are two types of tables that you can create in Hive. And the first one is called a managed table. Second one is called an external table. So there are two types of tables you can create in Hive, okay, named managed table and external table, okay. What we saw in the last class was an example of managed table. Now, how do you know that it is a managed table? So if you go to the Hive shell, and this is the table we created called taxi data, I can do a describe, then formatted, and let's say taxi data. So there is a command called describe formatted and then the table name, in my example taxi data. So when I run this command on the table, I see that the table type will be written somewhere. Yeah, the table type is a managed table. So this is something we ran in the last class. And what do you really mean by a managed table? A managed table is one where Hive is going to manage your data. So whatever data that you're storing, right, Hive will ensure that it keep the data in a specific directory. I also showed you that directory, if you remember. So there is a apps, Hive, warehouse, then database folder, table folder. So if you go to this location, you will be able to find your data. This is called a managed table, what we discussed in the last class. Now there is another kind of table which I want to show you today that is called an external table. So by default, when you're creating any table in Hive, it is called a managed table. If you just say create table, table name, if you're just creating the table, it is going to be something called managed table. On the other hand, there is another kind of table which we call the external table. Now, in order to introduce external table to you, let me pick up a data set first and then talk about it. Okay, so I will just see which data set I can take. If you give me one quick moment here. Where is my data? Yeah, case study. Oops, why this is like zoomed in? Sorry for that. Just give me one moment. Okay, real underscore estate. I just want to make sure that this is the correct one. Yeah. So let us assume that you want to analyze another data. So this time we are talking about a real estate data set. So let us suppose you're working for a real estate company, something like, let's say, Magic Bricks, or you might be aware of lot of real estate companies, right? So let us assume that you're working for a large scale real estate company, okay, where you are buying and selling houses online. So consider something like Magic Bricks. And let us also assume that your company is in US, okay, and you want to analyze some data using Hive. Now, if you look at the data, this is the property listing. So there is a column called street, you can see. So this is the street name where the property is there. Then there is the city. The city is actually Sacramento, Rio Linda, etc. Then there is the zip code or the postal code of the property. Then you have the state, like CA stands for California. How many bedrooms you have in the house, how many bathrooms you have in the house, what is the total square feet area of the house, what type of property it is. So there are two types of properties. One is called, residential property. Then there is something called condo. There is something called condo. Then you have a sale date, you have the price, and the latitude and longitude, the location of the property. So each record is actually talking about one house, its location, price, number of bedrooms, sale date, etc., etc. Right? And my requirement is this is real estate data, so I want to analyze it using Apache Hive. So usually what we do is that, like in the last class, what I have explained is that you create a table, then you load the data into this table. So that is what you call a managed table. Now let me show you what is an external table. So what I'm going to do, let me see if I can change it, if you give me a moment. Yes. So how do you create an external table, first of all? So let me show you the command which you can use to create an external table. Oops, I think when I copy pasted from Word, there is this problem. Microsoft Word always has this problem. Again. See, the problem is actually I'm messing with Microsoft Word. So let me copy from here and then keep it in a notepad so I can run the command. Let me make sure that the command is correct. Yes, it is correct. I hope it is correct. So I'll just copy this. Yes. So this is how you create an external table. First of all, I will explain what is an external table, but if you look at the table creation statement, you can clearly see that I'm mentioning create external table. In my last class, when I was creating a managed table, I was just typing create table, that's all. But here I'm saying create external table. So I'm using this keyword called external. Then this is the name of my table. It is called restate_ext, whatever it is. And then within brackets, I have the column names and the data type. So this is similar to a managed table. Even in a managed table, you have columns and data types, as you can see. Then you also say that the data that you're going to load is actually comma separated. But I'm adding an extra condition called location. So what is the primary difference between a managed table and an external table is that in an external table, you can decide where the data will be. So I'm going to tell Hive that, you know what, this is the table I'm going to create, and it is an external table, And my data is going to be in this location in Hadoop. I don't want to copy the data. I will keep the data in this particular location. So as you can see in my home directory in Hadoop, I'm mentioning that the data is in a folder called ext. So if you look at my Hadoop, let's open HDFS. And I can just go to, let's say, Files menu. Go to Files menu. And in here, there is this directory called ext. So here you can see there is a folder called ext. So I am telling Hive that, okay, my data is going to be here. And I don't want to move the data. I will keep the data here. So if you want to load the data into an external table, you don't say load data, blah, blah, blah. No, you don't run that command, right? In order to load the data into an external table, all you need to do is you just copy the data in this directory. So I can just come here and this is the file. I can just copy the data in this location because I'm telling in my statement that this is going to be the location of the data. And now if I do a select star from, let's say, re state underscore ext, let's say limit 5, you have the data. Now, unfortunately, we also loaded the header as the data. That is why the first row is kind of like null, null. Don't worry about that, but we are able to load the data. So what is the difference between a managed table and the external table? The primary difference is the location. A managed table always keeps the data in apps, Hive, warehouse, DB folder, table folder, etc. An external table, you have the freedom to keep the data wherever you want. And how do you know that it is an external table? So if I say show tables, the RE state is our external table, and I can say describe formatted RE state ext. And when I say table type, it clearly says it is an external table. Also, when I look at the location of the data, it says the location of the data is this folder. So clearly, we can see that the external table points to a different location. Now, since we have loaded the data, let us run some very basic queries. Okay, so what I'm going to do, let's see if we can find out some very basic answer to some very basic queries. So I don't know whether I'll be able to directly copy paste from Word. No, I cannot. See, the problem is, since it is Word, right? So I will probably copy the whole thing into Notepad and then run it. Yeah, so I can just copy this into my Notepad. Right, because these, what you say, quote, single quote character has a problem in Word. That is why it is giving an error. So I guess here it is fine. Here also fine, I guess. So let's say we want to run some very basic analysis on this data. So one question I want to answer is list all the residential which is not less than 10,000. So I want to find out all the houses whose price is less than 10,000. Now there are two types of houses, residential and condo. I want only residential. So I can simply run a select star from the table where I can give two conditions. Price is more than 10,000 and flat type is residential. So you can use a very simple where close to get this answer. Let's try that. You can go here. I can say select star from table where price is this condition, flat type is residential. Oh, okay. I think the table name is different. What is the table name? RE state underscore ext. So I just need to add this table name if you don't mind. Underscore ext underscore ext. Yeah. So let's run this query now, see if it works. Yes. So you can see all the residential listings whose price is more than 10,000. How do I know this? Because if you look at the pricing column, you can see that it is more than 10,000. Another query, in Sacramento City, which residential type has more than 800 square feet? Display their respective details such as the street name, square feet, sale date, and city. So I want to filter the data for city as Sacramento. Then I want to look at all the plots where the square feet is more than 800. So a similar query, you can say select street, square feet, sale date, city name from the table, and you can say where the condition is city name is Sacramento, square feet is more than 800. Here is the answer to the query. So as you can see, all these records are from Sacramento, and all these are having more than 800 square feet. Okay, what else we can do? I want to find the cheapest condo in California. So California is the state, and I want to find the cheapest condo. Okay, and I want to get the which city the cheapest condo is, the street, and the price. So we need to give a condition like where flat type is condo. Then you can do a order by price. So what do you mean by order by price? Order by price basically means it will sort the data based on price. And by default, when Hive is sorting your data, it will sort in ascending order. And then you can say limit 1, meaning I want only the first record. So I will first filter that for flat type is condo. Then I will sort it based on the price column. I will take the first entry. So let's run this query. This will fire a MapReduce job. Because it has this order by close, it is going to fire a MapReduce job. Let's wait for the output. As you can see, this is the cheapest condo. Its price is 40,000. This is in Sacramento. So we got the output. Okay. One last query on this data set. I want to list the top 5 residency details which lie in the budget of 50,000 to 100,000. So I want like top 10 houses which are in the budget of 50,000 and let's say 100,000. And also it should have an area more than 1,250 square feet. Minimum there should be 3 bedroom and 2 bathroom. So again, the query will be select. You want to select street, city name, zip code, state, bedroom, bathroom, square feet, flat type, sale date and price. I want all these columns from the table where my condition is what? Price should be in this range. Square feet should be more than 1,250. Number of bedrooms should be more than 2. Number of bathroom should be more than 1. Okay, I think number of bedroom is 2, not 3. Bathroom is 1. Okay, then I want to order by price, limit 5. So I want only the top 5. So I will order by price and limit 5. It's not the top 5 list. I will say the 5 cheapest. Because when you do order by, what is going to happen? It will sort the data in ascending order. And when you say limit 5, you are going to get the bottom 5 based on price. So you can say, I want to list the 5 cheapest residencies. So let's try this query, see what happens. Let it run. So it is firing a MapReduce job. Yes, so we can see the output in here. So there are only 3 houses matching with our condition. Okay, so even though we were looking for the bottom 5, there are no 5, there are only 3 houses matching with our condition, we can see there. All right, so now if I say show tables, there are 2, there is a table called Star Wars. Let me drop that, drop table Star Wars, because I was using that table for something else. We don't need it for today. So if I say show tables now, there are 2 tables. One is the taxi data table, which we created in the last class. Second is this real estate table, which we created today. What is the difference? The taxi data is a managed table. Real estate is an external table. Now let's try to do one thing. So maybe some of you are wondering, is this the only difference between what you say managed table and external table? So what is the primary difference between managed table and external table? The location where they keep the data. But that is not the only difference. Let us try to do one thing. Let us try to drop the managed table. I can say drop table taxi data. So I dropped this table called taxi data. This contains the data that we loaded yesterday, the yellow cab data from New York, right? Now, what do you think could have happened to the actual data you had in this table? The actual data also will be deleted. So I dropped the table, that is correct. But after dropping the table, not only the table is gone, the data is also gone. I can prove it. If I go to my Hadoop, I go to apps, there is Hive, there is warehouse, and our database called Board Infinity. If I open this Board Infinity database, nothing is there. So previously we had a table directory and the data inside that. So what is going to happen if you drop a managed table? It not only drops the table, it also deletes the data that you store in that table. However, this is not the case if I drop an external table. So if I say drop table restate ext, so I just dropped the external table. So now if I say show tables, the table is gone. All tables are gone. However, since my external table was pointing to another location for the data will remain there. So if I go to my Hadoop, and there was this directory called ext, if I open that, here is my data. So when you drop an external table, the data will not be deleted. This is the actual difference. So if you have a managed table, if somebody dropped the table will be gone, the data also will be gone. If you have an external table and then somebody drop the table, only the table will be gone. The data will remain. That's the basic difference between managed table and external table. Okay. Now, another point that I wanted to talk about is you can also use this graphical user interface called Hue to create a table. So in Hue, you can see the databases. So this is Hive actually, and we can look at our database called Board Infinity. I think it might have to refresh. Let's check, okay? Yeah, Board Infinity. So I can go to this Board Infinity database from the graphical user interface, and I can create a table from here without running a command in the, what you say, CLI. I can actually create a table using the graphical user interface. So let us try to create this yellow trip table again, but we need the data for that. So I think I deleted the data. Just resume sync, okay. So I will just upload this data again, to Hadoop, our yellow data. I think it is here. So I will just upload this data in Hadoop. And usually what you do, you open the Hive shell, then you say create table, blah, blah, blah. But you don't have to do that. From Hue, you can actually do it. So what you can do is, I have selected this Board Infinity database. There is an icon called create table. I can click on this create table. Okay. Now it will ask me, do you want to pick the data from a file? So I can say, yes, I want to pick from a file. I can browse here and then select my yellow file. Here is the yellow file. So once I drag the file, automatically my Hue is going to tell me that, hey, I see the separator is comma, the record separator is new line, and then I see that there is a vendor ID column, pickup date, passenger count, trip distance, longitude, rate code. So it's going to sample my data and say that, hey, this is how the data looks like. If I say next, it automatically says that, okay, I will create a table called yellow. Then it will say the property, it is a text file. So here I can say whether I want a text file or a Parquet file or a CSV file. There are different formats. I'll say text file. Then I can look at the column name. So there is a vendor ID column. It will treat it as big integer. Date, time, it will be timestamp, so on and so forth. So it will pick up all the column and data type. I say submit. It will create the table for me. So even without learning the command, you can come to this graphical user interface and it will create a table for you. So I just submitted this and we have to wait for a moment for the table to get created. And yes, so the table is created. You can see that the overview of the table. So these are the data types and all. There is a sample of the table. And I can also query the table from here. I can say, so remember yesterday we were running the query, right? Where is it? Here. So I can run one of the query. So let's say, select average total amount. So let's say this query. you want to find out the average trip amount, I can just run the query here, hit the play button. It will run the query for me and show the output in the screen. So you can also work with Hive from a graphical user interface, something like Hue. So it is running the query for me right now, and it is going to show the output. Yeah, so the output is actually 16. Not only this Hue also allows you to visualize your data. So if I run a simple query like select star from yellow, okay, I think I need to mention select star from board infinity dot yellow. So if I run a select star query, let's say it is picking up select star only, so you are getting all the columns. But from this output, so this is the select star output, I can create like a bar chart if I want. I can go to this visualization. I can say I need a bar chart, and then I can say the x-axis is, I don't know, let's say payment type, okay? And y-axis is, let's say, fair amount, okay? And let's see if I can do a, yeah, so vendor ID. So you can see, create things like bar charts and pie charts, everything using the GUI if you want, right? So that is just an extra option. If you're comfortable with doing bar charts and groups and all, you can actually do that. So here I have created a bar chart. Let's just expand it a bit. So here you can see that this is grouped based on, vendor ID, or let's say I don't want to group total amount. So you can see all the total amounts in the bar, grouped by the amount. So you can visualize the data as well if you want. Okay. So that is manage table, external table in Hive. I should also some more information about Hive before we wind up the topic of Hive, which is, see, originally when Hive was created, okay, what it used to do, you write a query, it will convert the query into a map reduce job. That is what you see here. And this is with Hive version 1. So Hive version 1 is actually pretty old, right? So initially with Hive version 1, or I would say even starting with version 0, the original idea of Hive was that, hey, I'm going to write a SQL query and you convert this into a map reduce job. The problem here is map reduce is pretty slow. Okay, and now I can share some of my work experience. So in the older days, not now, like in 2012 and 2013, when I used to work with my clients, they used to run Hive queries, which will take like 5 hours to complete. So you will submit a query, it will take 5 hours to complete. Partially because the data is big, and partially because Hive is terribly slow, because it internally uses MapReduce, and MapReduce is slow. You cannot help it actually. So the community was actually searching for a little bit of improvement in the speed. So people started using Hive, and they were happy because they can write SQL queries and all. But then they were like, okay, can we do something to speed up the query? Accordingly, there was another SQL engine which was created. I mean, not for Hive. There is another another execution engine called Tez. Tez is an execution engine very similar to MapReduce. If you look at Tez, it also has this concept of mapper, reducer, and all. But where it differs is that Tez is much, much faster than MapReduce. Okay, so if you look at here, you can find Tez, tez.apache.org. So Tez is again an open source project, which initially was invented to figure out the flows of MapReduce and make it faster. So Hive can actually use Tez also as an execution engine. So if Hive is using Tez as an execution engine, it is probably 5 to 10 times faster than Hive with MapReduce. So in the modern day architecture, we never use MapReduce. So one thing that I have to tell you is that MapReduce is gone from the industry. Nobody is using MapReduce. So even if you run Hive in the modern day Hadoop clusters and all, it always uses Tez as the execution engine. So this is not existing. But I showed you because it is a training session, and it does not make a difference whether it is Tez or MapReduce in a training. But in the real world, if you see Hive, chances are very high you will see Tez jobs running rather than MapReduce jobs. So that point I wanted to clarify. Now I will pick up some questions. Let me know if you have any questions on Hive, anything that you want to ask specific to Hive. We will pick up some questions. If you want, you can take a moment and then think about the question, and then I request you to type it in the chat window if possible. If it is possible, you can type the questions in the chat window. Okay. I guess we don't have much questions, right? Okay, I mean, in case you don't have any questions, that's fine. Another question that usually people ask is this the only, what you say, engine that you have, right? Yeah, I saw Hive. Is this the only SQL engine that you use? And the answer is no. Hive is probably one of the oldest SQL engine that we have. Yeah, it is actually a very oldest engine, right? But Hive is not the only SQL engine in the world of big data. So there are many things actually, many SQL engines are there, and Hive is kind of like everywhere, you know. So Hive is everywhere, and many people actually use what you say Hive as well. But when you look at it, there are many other SQL engines available there. There are many other SQL engines. For example, some of them probably we can just go through, even though we will not be able to like have a discussion on them. I think if you at least hear about them, that will be nice. So some of the other SQL engines which we have is, one, there is something called Impala. Impala is kind of like a competitor to Hive. It's not a competitor, but Apache Impala is another SQL engine. Impala was created in 2012. So Hive came in 2007, okay, and Impala came in 2012. And why Impala was created was to address the slowness of Hive. So the community was like, hey, it's really slow. Can you do something? And the company called Cloudera, they created Impala. So the speciality of Impala is that if you write a query in Impala, there is no map reduce. It does not convert to map reduce or anything. It directly runs your query, and it is really faster when you compare it with Hive. In some of the benchmarking tests, it was proven that Impala queries run 50 times faster than Hive query. So accordingly, many big data projects started using Impala. Now, if you think about it, you may start to wonder if Impala is so great and if the queries are also really fast, why not everybody is using Impala? You can just use Impala. Why are you still using Hive? So there is a flip side for Impala, which is Impala queries are not fault tolerant. So if you're running an Impala query and during the execution, if any machine crashes, your query will be aborted. So Impala queries are not fault tolerant. That is the drawback of Impala. Okay, but Impala is very popular. The other one which is very popular is called Drill. Apache Drill. Drill is again another SQL engine. Drill is promoted by this company called MapR. There is a famous big data vendor called MapR. MapR promotes Drill. I can consider Drill very similar like Impala, like it's super fast in that way. Drill is really fast, and Drill is also fault tolerant. So I would say that it's fast, it is fault tolerant, and probably many people might be interested to use Drill, right? Then there is definitely something called Presto. Presto is another popular SQL engine. Okay, so Presto was created by Facebook, right? And the speciality of Presto is that it can handle, so the queries will run really fast on huge amount of data. So the use case of Presto is like you have petabytes and petabytes of data, you want to run queries, then Presto is your answer, right? So there is Impala, there is Drill, there is Presto, there is Hive. There is also something called Spark SQL. We will see that in the Spark class, but there is something called Spark SQL as well. Which engine to choose, that is completely up to you. So all these engines, SQL engines, will have some advantage and some disadvantage. Now, from my experience, one thing that I have been seeing in the industry is that there is a lot of shift towards cloud computing. So you have this cloud platforms, right? And I still remember originally when I started working on big data, all the Hadoop cluster, Spark cluster, everything was inside the company. So I remember like in 2012 and all, right, when we started working with Hadoop, when you say Hadoop cluster, every company will have a cluster within the company, like a data center. So you can actually go to the company and see the cluster because it is like a physical machine, like a data center. But very soon the problem started like, it is very costly to set up these machines and all, right? Servers, everything. So a solution was to migrate to the cloud. So many companies over the period of past maybe 5 to 8 years have migrated to different cloud platforms. Amazon Web Services, Google Cloud, Microsoft Azure. So all these cloud platforms provide big data solutions. So that is one trend which I have been seeing in the world of big data. Accordingly, when you go to the cloud platforms, they will have their own data warehouse, their own SQL engines, etc. So there are many companies who are very popular in this section. One of the thing which is very popular these days is there is a cloud-based data warehouse called Snowflake. So Snowflake is actually one of the most popular cloud-based data warehousing platform. So instead of setting up everything inside your company, what you can do, you can contact Snowflake and they will build your entire data warehouse in the cloud, right? Also, it is cheaper and much more manageable compared with your on-premise systems. So a lot of my customers are actually using Snowflake these days because it is cloud, it is cheaper, and so on and so forth. Okay, so always these new technologies are there. You cannot stick with one technology. There are new technologies everywhere. Now we will take a break and then continue. So you guys also can take a break if you want. I will write it here. We are on break. Will resume at 8:10. Thank you. All right, welcome back. Any questions so far? Let me know. I'll just see if we have any questions. Nope. Okay, no problem. So I guess we can go move to the next topic, which is SQOOP. Let me see if I can bring a slide on SQOOP, okay? Which I'm wondering where it is. So it should be in my Google Drive. SQOOP. Yes. So what I will do, I will talk a little bit about SQOOP, and then I will come to the hands-on part of SQOOP. So there is a little bit of hands-on part in SQOOP as well. We will do that. But first we will talk a little bit about SQOOP, and then we will come back to the hands-on part. Okay, great. So Apache SQOOP, right? And what it is, that's the question that we have to solve. So if I want to summarize SQOOP, say like in a single line or a single picture, this will be it. Okay, so this is SQOOP. As you can see, what this slide actually says is that SQOOP is nothing but a data transfer tool. So if you ask me what exactly is SQOOP, I'm going to say that, hey, it is nothing but a data transfer tool. So it is not a developer's tool. It is not a programming language or anything like that. It is nothing but a data transfer tool. I'm sorry. So SQOOP basically allows you to send data either from Hadoop to a SQL store or from a SQL store to Hadoop. So the classic use case of SQOOP is that, hey, I have an RDBMS, right? Let's say I have MySQL or Microsoft SQL or Oracle, any of the RDBMS platform. I want to copy the data to Hadoop. How do I do it? So SQOOP can help you, or vice versa. What do you mean by vice versa? You already have the data on Hadoop. Uh, you already have the data on Hadoop. You want to bring it back to SQL. Again, you can use SQOOP. So SQOOP is bi-directional. Okay, so it can transfer the data in two ways, either from Hadoop to, let's say, RDBMS, or it can be RDBMS to Hadoop, both ways. So that is basically the purpose. And if you understand a little bit about the data warehousing industry and all, you know that there are ETL tools, right? There are a lot of ETL tools actually, and SQOOP is what we call the ETL tool on Hadoop. So basically, it is a data transfer tool or ETL tool that we have on Hadoop. That is SQOOP. Okay. Now let's get into the details of this. So what the slide says, SQOOP is a tool designed for efficiently transferring bulk data between Hadoop and structured data stores. What do you mean by structured data stores like RDBMS and all? SQOOP can import the data from, let's say, RDBMS kind of like platforms, either to HDFS or Hive or HBase. So either it can directly bring it into Hadoop, or it can actually bring it into Hive as well. Both ways it can do. Okay. You can also do something called SQOOP export, which basically means from the, let's say, Hadoop, you can copy the data to RDBMS. So import, scoop import means the data is in, let's say, MySQL, you want to copy that to, say, Hadoop. Scoop export, the data is in Hadoop, I want to copy to RDBMS. Both ways it will work for you. Okay. And Scoop is a data ingestion tool, and we already know what it does. It is simple as the user specifies what and leave the how. So how does Scoop actually work? Well, it's a command line utility. Scoop is a command line utility. So you have to run commands for Scoop to work. But it's very straightforward, the commands that you want to run, right? And Scoop was developed by this company called Cloudera. So, Cloudera developed Scoop. Why do you need Scoop? Very simple, because a lot of organizations are actually migrating to Hadoop, and they have a requirement, like they have a lot of data in RDBMS and they want to get it into Hadoop. That's primarily we use Scoop. And this is the same slides we are talking about. So now let's look into a bit more details about Scoop. So what it exactly does under the hood. So it allow data import from external data stores. We already saw that. It parallelizes the data transfer. So that's a very interesting thing that Scoop does. In fact, what Scoop does is that if, let's suppose, you want to copy a table. I want to copy a table from MySQL, imagine. So Scoop, what it does is that it is going to divide your table into multiple small parts, and then it is going to launch, let's say, a MapReduce job or multiple MapReduce jobs to copy the data parallelly. So Scoop parallelizes your data transfer. What it means is that it's not like Scoop is copying the entire table in one shot, right? It will divide your table and then it is going to parallelly copy the data to speed up the process. Okay, so that is how Scoop works. We will see that. And copies data quickly, make analysis efficient, and so on and so forth. So we saw this already. Scoop provides a pluggable connector mechanism for optimal connectivity to external systems. So if you are wondering, hey, how Scoop can copy my data from MySQL, then Scoop basically uses a connector. This connector is nothing but your driver. For example, if you want to copy the data from, let's say, MySQL to Hadoop, then definitely you need to talk to MySQL to get the data. How do you talk to MySQL? You need the proper driver, right? Then only you can talk. So there is a connector mechanism or the driver which Scoop uses to connect with the, RDBMS, any platform, and then copy the data. So depending on what platform or which platform you are using, like Oracle or MySQL, you might have to use a proper appropriate connector or appropriate driver, I can say. Okay. Now, who uses Scoop? So there are many companies who actually use Scoop. There is a company called coupons.com. I don't know how many of you have heard about this company. It's an online marketing company, coupons.com. They have lots of data in IBM Netezza. IBM Netezza is their data warehousing platform, and they use Scoop to bring the data to Hadoop. The Apollo group also uses Scoop, and there are countless other Hadoop users who basically use Scoop. Okay. Now, this is what we need to understand before we go to the hands-on part of Scoop, right? So the data set being transferred is sliced up into different partitions. So what's going to happen if you want to copy a data? The data set in this example is a table. It is first sliced into different partitions. So like if you have, let's say, 1,000-row table, it is divided into multiple parts. Then a map-only job is launched with individual mappers responsible for transferring a slice of data. So by default, what happens is that Scoop is going to expect, your RDBMS table to have a primary key. So there is this concept of primary key, right? So by default, what happens? Scoop expects that a primary key in your source table. Okay, this is the default assumption. Even if there is no primary key, you can do it, but by default, it expects a primary key. And then what it does is that it will divide your table into 4 partitions, and then it will launch 4 mappers, and each mapper will copy one part of the table. That is how the copy operation happens. So you can see the different steps. Maybe I'll just go through this and then talk about a couple of things more. So how Scoop import helps? Step 1, Scoop introspects database to gather the necessary metadata. So it is going to connect with your MySQL and say that, hey, this is the table, these are the columns, etc. Step 2, a map-only Hadoop job submitted to cluster by Scoop and perform the data transfer using the metadata captured in step 1. The imported data is saved in HDFS directory. By default, these files contain comma delimited fields. So this is how the Scoop import happens. Now, rather than talking about Scoop, probably we can do a small demo of Scoop so that it's easy for people to understand what it is. Now, to do the demo, we need some data, right? So what I'm going to do, I'll just connect with our lab. Let me adjust this, okay? You close these unwanted documents. Okay, I'll just yeah. So what I will do, the first thing which I'm going to do is, let me see if I can find the commands, okay? So guys, please give me a moment to make sure that the command is correct. Yes, it is correct. Retail DB customers. So let's do one thing. I have this CloudX lab, right? In the CloudX lab, fortunately, we have a MySQL database. So here you can see there is a MySQL database, and we can connect with this MySQL database, and we can find out, let's say, a table to copy, right? So anyway, that is required. So I'm going to copy this command to log on to MySQL. Once I'm inside MySQL, I'm going to say show databases. So there are many databases. I can use a database called Retail DB. And here, if I say show tables, there are many tables, but I guess we have a table called customers. Where is the customers table? So if I say select star from I think this will do. Yeah. So there is a table called customers. So if I say select count star from customers. So this customers table has around 12,435 rows. So it is a pretty good table for us to experiment with, right? And if I look at the schema of this table, I can say describe customers. You can see that it has, there is a customer ID, first name, last name, email, password, street, city, state, zip code. So this is the table which is inside MySQL and which I want to copy to Hadoop. This is a table which I want to copy. Okay. And you can also see that the first column called customer ID is the primary key here. So there is a primary key column which satisfies our requirement. So we can probably take this as our source table, right? So this is the table which I'm going to use. I'm going to quit from here. And let me reconnect, okay? Because it is a bit slow. Also, I need to make sure that a couple of more things are in place. Yes. Right. So now we are ready. So like I said, Scoop uses commands. It's a command line utility. So you need to use commands to run Scoop. No, it will not understand any GUI or anything. So there are certain commands which are specific to Scoop, which you can use to run Scoop. And usually when you start running these commands, the first command that you normally run is the list databases command. So this command is called list databases command. You can see that it says scoop, then it says list databases. So I just want to list databases. Then there is a connection string. So this is the MySQL connection. So MySQL is accepting a JDBC connection, and this is the server where my MySQL database is installed. The DNS name of my server, and then I provide the username to connect with MySQL, the password to connect with MySQL, and this is supposed to list all the databases in MySQL. Let's see. So as you can see, it is able to list the 3 databases which we have in MySQL. So information schema is like a metadata. Then you have retail DB, ScoopX. So we are able to list all the databases that are there. Step number 1. Step number 2, I can also run a list tables command. So here I'm saying that, hey, Scoop, I want to list all the tables, okay, inside this retail DB database. And you provide the connection string, username, password. If I hit enter, you can see that all the tables are getting listed. So this proves the concept that we are able to list all the databases and tables and all. Now, before we try bringing the data, we have to make sure that we have permission to copy the data. So I can see the database. I can also see the, I can see the database, I can see the table, but I have to make sure that I have read access on the data. So there is an eval function you can run. The eval function is used so that you can run a SQL query on the source table and get the output. So I can say scoop eval, connection string, username, password, and then I can say query and whatever query that you want to run. So I'm going to do a select star and see we are able to list the data. So this proves that you are able to run a query and see its output. That's also fine. And this eval can be used to even run any SQL query. So here you can see I'm running the eval command and the query is create table dummy1 with I integer. So I'm using Scoop to create a table. Maybe not a real life use case, but you can do that. So it says 0 rows updated. You can even insert a data into that. So I can say scoop eval, insert into dummy1 value 1. Yes, and now I can say select star from there. Yeah, you can see that we created a table called dummy. We inserted a value 1 and we are also able to see the value 1. So, I mean, in the real world, you will not be creating a table using Scoop. But my point is that using the eval function, you can do all these things actually. Okay. Now let's try to do the import actually. So what we can do in the scoop import, scoop import is actually used to bring the data from, let's say, MySQL into Hadoop. And this is the command we use for that. So the command is like this. You say scoop import, which means I want to import the table. You have the connection string, username, password, and the table that you want to import. And then you mention an argument called warehouse directory. This is nothing but the destination or target directory where you want to copy the data. And this is in Hadoop. So I'm saying that in Hadoop, under my home directory, create a folder called scoop import. Inside that, create a folder called retaildb, then copy the data. So let's hit enter and see what happens, okay? We'll just wait for a moment because this is actually running a map reduce job, or I can say a mapper only job. So if you look at this command I ran, I mean, this was to import the data. This was the whole command I ran. This is the place where I ran the command. There are some very interesting points in the output of this command. So this command basically copies the entire table to Hadoop. And it was successful. The table is also copied in Hadoop. But we can find something very interesting in this. It says running scoop version 1.4 and all, blah, blah, blah. That's okay if you scroll down. It says, where is it? Yes. Number of splits 4 from 1 to 12,435. Now remember I told you by default when Scoop copies any table, it is going to split the table into 4 partitions. You can see that here. So Scoop is telling me that, hey, you have rows from 1 to 12,435. So total, what you say, 12,435 rows are there. Okay. Now I'm going to split that into 4. Okay. And when you split it into 4, the split size is going to be 3108. So if you do the math, 3108 by 4. Yeah, 12,432, roughly the same, right? So each split will contain these many rows, total 4 splits, and that is how it divides your data. You can also see that it says number of splits 4, and then here you can see it is firing a mapper only job. So Scoop is going to launch 4 mappers because there are 4 splits, and each mapper will copy one part of your table. So you can see the map reduce job running. Finally, it says transferred 931 KB, retrieved 12,435 records. Okay, so does that mean the import was successful? Let's verify. I can go to my Hadoop, refresh here. And check here. There is a directory called Scoop Import. Inside that retail DB, inside that the table folder. As you can see, there are 4 files in my output folder. Why there are 4 files? Because we were having 4 mappers. Each mapper will produce one output file. And if I open any one of this file, you can see the table. So we are able to successfully bring the whole table into Scoop. This is just the example, right? Now I will delete this folder because I will be running again these commands. So what will happen if the folder already exists? It will throw an error. So I will just delete this guy. Okay. Now what are some of the other arguments we can use? So there are many arguments you can use. For example, I can say scoop import, all these things. Okay. And I can say number of mappers. So what happens is that by default, you are splitting the table into 4. That is what we saw. But many a times what happens is that you might want to split it either more than 4 or less than 4. Because see, if I'm copying a table which contains, let's say, 100 million rows, maybe I want to divide it into 100 partitions and copy. Then only it will be faster. So you can control it with this argument called number of mappers. So let's say I do a number of mappers 10. So let's see what happens. So I add an extra argument called number of mappers 10. So this should split your table into 10 and copy that. Let's see whether it is working, just to demonstrate that. Oops, it says import failed. Let's see why this job. Oh, I think in our cluster, it is not set to actually use 10 mappers, right? So let's try with 2 mappers. Let's see. Let's see what will happen if I say 2 mappers, just as an example, okay? Maybe the directory got created. I need to clear that directory. So let's see what happens with number of mappers 2. Let me just check, okay? Oops, I think there is some problem with MapReduce, guys. Okay, it is failing, not because of our. Let's see what is there. Okay, says permission denied. Oh, okay. I'm sorry, guys. The command, there is a slight difference. sorry, the location was different. So this will be, table will be customers. So I need to make sure that all these things are correct. Yeah, now let's see whether it works. I just need to make sure that this works. Hopefully it will work. Yes, it worked. So this time what I did is that I added this argument here. You see, number of mappers 2. So you can keep this any number. Now in our CloudX lab, it does not allow, I think, more than 6. That is why when I kept it as 10, it failed. But in a real production cluster, this can be any number. So I kept it as 2. And now if you look at the output, there will be only 2 files in the output directory. Scoop import, retail DB, customers. See, there are only 2 files. Why there are only 2 files? Because 2 mappers were launched. That's all, right? So that will happen like that. Okay. So you can always control the degree of parallelism. That is my idea, right? So in a real production environment, you might want to say number of mappers 100. Okay. Now, if you want to copy data again, you can add this append operation. I don't want to show that because I deleted the data. Now, let's say, so the default condition I told you is that whenever Scoop want to copy the data, right, you need to have the source table with primary key. That is a condition. Now we know that it's not always possible to have a primary key. So let us see what will happen if we try to copy a table which does not have a primary key. So I can just go here, try to log on to my SQL. And if I say show, let's say use retail DB, we already know that this customers table has the primary key, so I don't want to touch that. There is another table called customer underscore, there is some name. Let me do a show tables, okay, to see all the tables. Yeah, there is a table called customers underscore no PK. Well, basically it is the same table with only one difference. If I say describe customers underscore no PK, you can see that it has exactly same column names, same data types, and the same data as well. The only difference here is that in this table, there is no primary key column. So what will happen if I try to copy a table without primary key using Scoop? Let's check that. So I'm going to run the command first just to check. Let's run the command first. Yeah, so I'm going to say Scoop import my connection string, username, password, table name is this, location is this. Let's try to run this. So when I try to run this, I get an error. It says error during import, no primary key could be found. So by default, when you try to copy a table and the table does not have a primary key, you will get an error. But what you can do is you can use this argument called split by. So what I'm doing here is that I'm going to say that, hey, I want to copy this table, right? But unfortunately, I don't have a primary key column. But please consider this column like my primary key. So the argument is split by, and if I add it, I should be able to get the data. So as you can see, now the MapReduce job is running and we are able to import. So in the real world, what happens, there can be many situations where you have a table without the primary key. In that example, in that case, what you need to do, you need to identify a column which can act like a primary key and pass it as an argument called split by. Now, in my example, it is the customer ID itself, so I don't have to worry. Ideally, this column you are giving as split by should have unique values. Right? So here you can see I have customer ID. Okay, let's look into some of the arguments you can use more. I think this is already discussed. You can also change the default delimiter and null values. You can see what are the delimiters and so on and so forth. And another interesting thing that you can do is you can do a Hive import. So I'm going to say the database is God Infinity. And yes. So Scoop can also import your data into a Hive table directly. And I think that will be more justifiable because when you're copying the data to Hadoop or HDFS, you're blindly copying as a file. But here I'm copying from an RDBMS to a data warehousing platform. So the command is like this. You say scoop import and all the arguments. Then you say Hive import, meaning I want to copy this to Hive. You mention the database name in Hive, the table name in Hive. Optionally, you say number of mappers 1. So let's run this and see whether it gets copied into Hive. It's running now. And it seems the data is loaded into Hive. How do you verify? So let's start the Hive shell. Use board infinity. When I say show tables, there's a new table called cust. If I say select star from cust limit 5, here is the data. So we are able to successfully import from MySQL directly to Hive as well. So either you can import to HDFS or you can import to Hive. That is your complete choice. Now, this is what I plan to cover today. So I will wait for your questions. I will stop sharing my screen and I will keep myself on mute. In case if you have any questions, you can ask me. Or in case if you do not have any questions, then please feel free to drop off from the webinar as well. I will wait for 10 more minutes and then I will end the session. Thank you. Good night.